Hi guys, in this video we're gonna give our ranged enemy character the ability to find a cover when he's hit by our bullets, by our guns. So he's gonna find the nearest cover to him. So before that, I'm gonna do some organization to the world outliner first. We have the geometry folder, the lighting, the sky effects folders. So I'm gonna add a new folder, two new folders actually. The first one I'm gonna call pickups, and the second one I'm gonna call enemies, just to keep things organized in a big world outliner. I'm gonna I'm gonna select all the pickups first. Pistol ammo pickup, the gun, shotgun ammo pickup, shotgun pickup. Gonna move them to the pickups folder. That should be it. And then I'm gonna go to the enemy related stuff. That is the ranged enemy himself, the 3 zombies, the recast nav mesh, the 2 nav meshes, bounce volumes, and I'm gonna move them to the enemies folder. This way we have things organized inside our world outliner. Then I'm gonna go to the ranged enemy folder here, and I'm gonna create two new folders. The first one I'm gonna call animations, because we have a lot of stuff as of now inside our ranged enemy folder, so we should organize things a little bit. The third folder I'm gonna call it what should I call it? AI. Then I'm gonna select all the AI stuff: controller, player context, blackboard, behavior tree, fit shoot AI task and the test player context, track player, all this AI stuff, assets, and I'm gonna move them to the AI folder. Move here. The rest are animations and blank space, an MPP, moving them to the animations folder. Move here. I will keep these two assets, the ranged enemy class and the ranged enemy gun. So guys, now we should start working on the ranged enemy finding the nearest hiding location to him. First of all, we're gonna create a generator. So each environment query have a generator which generates the locations or the actors around the query or the given context. So here we're gonna create our own custom generator, which is gonna generate us hiding locations around the player character, which is us. So I'm gonna access the AI folder, and here I'm gonna right click, create a new blueprint class, and we're gonna search in all classes for a generator. We're gonna use the environment query generator blueprint base class as a parent. We call our new generator hiding locations generator. We're gonna access this class. So we're gonna override just one function, the only function inherited from the parent class, which is doItem generation. This is the function which does the heavy lifting, generating the locations or actors for each generator. So there, I'm gonna start by adding a for loop a simple for loop, and then gonna set the first index to 0 and the last index to 35. For each index we're gonna multiply it by 10, so we're spanning all the angles from the 0 to the 360, snapping 10 degrees each time. So gonna multiply it by 10 degrees. Then I'm gonna make a rotator. Inputting the new angle in the yaw parameter. What I'm gonna do now is I'm gonna rotate a vector, which is the x equals 1 vector, a unit vector. So I'm gonna search for rotate vector. This function, gonna input my rotator in the b parameter, a parameter x equals 1. So we have a unit vector varying in rotation each time from 0 to 360 degrees rotation in the yaw rotation. So then I'm gonna get my player character, get his location, should be actor location, there it is, and I'm gonna project this location to the nav mesh, to the navigation plane, so we have the location in the navigation plane. Project point to navigation. Then what I'm gonna do for the filter class, I'm gonna select recast filter, use default area, this one. Now I have the location projected on the navigation plane, the nav mesh. What I'm gonna do next is I'm gonna do line tracing, line trace by channel, of course, for the purpose of what we want. We're gonna start by multiplying this vector to create a bigger vector by a float. We're gonna promote that variable to variable. The float input, and it's gonna be gonna name it circle radius around player. So this is the starting, that should be the starting point of the line trace. We're gonna add it to the location, the projected location of the player, to obtain the starting point. So this is the starting point of the line trace. So we have, I'm gonna use my mouse cursor to explain. We have our player character here. We create a unit vector which goes from 0 to 360. We multiplied it by this variable, which we're gonna set it to a default value of 1000. So we have a bigger vector going from the player character, a bigger vector. It's gonna go from 0 to 360, snapping 10 degrees each time. Each time we're gonna add it to the location of the player character, so we have the starting point of our trace. Each time we start 0 degree, for example here, our player character is here, 0 degree for example here, then 10 degrees and 20 degrees and until we get to 360 degrees, and we line trace each time from there to the location of the player character, checking to see if we hit something in the middle. This is gonna be our cover point, our returning cover point. I hope this is clear. Then the end point, of course, as we said, it is the location of the player character. Projected to the nav mesh. Now that we did our line tracing, we're gonna check to see the result of each line trace. So I'm gonna connect this to the loop body, the line tracing. So I'm gonna just move this a little bit down, move this a little bit up for a clear blueprint, and I'm gonna connect the line trace there. What he's doing should be like that. Alright, and then I'm gonna check to see if we hit something in the line trace for a cover point. We're gonna break the out hit result. So break hit result, expand the structure. So if we hit something, we're gonna get the impact point. So, and the impact normal. So this is the normal of the impact, the unitary vector which goes from the impact point on the direction back on the direction of the line trace. So I'm gonna get first the impact point, and first I'm gonna get rather the impact normal and multiply it by a number of 50, a float 50, and then I'm gonna add it to the impact point to have another location further back from the location of the hit. So further by 50 units. So vector plus vector there. Then I'm gonna drag this location, the resulting location, lift the resulting location a little bit up by 100 units. So this is the cover point. We're gonna create a new variable for our generator, which we're gonna call returned cover points. And it's gonna be of type vector, and it's gonna be an array of vectors. So these are the cover locations, the returned cover locations. What I'm gonna do next is I'm gonna get this array, search for add, to add the new cover location to that array, this one. Now that I've done all this, I'm gonna go to the completed output of the loop node, of the for loop node, the completed output, the completed pin rather. Then I'm gonna check to see if I have something in my returned cover point array. So I'm gonna get his length, gonna do a test there, equals 0. If it's equals to if it's equal to 0, gonna connect this to the completed down. If it's equal to 0, we're gonna return default value cover location of 0. So if we have no hit around the player character, we're gonna return a location of 0 as a cover point. So true, add generated vector, a function of the generator class 0, and we call the return node. So we call the return node there. If it's false, if we have hits around the player character, we're gonna do for each on this array and return each time the vector, the cover location inside the array. So for each loop spanning the values of this array element, the vector, the location inside the array, the given index. Alright, okay, so that's it, a generated vector. We're gonna return each locations inside the array. So okay, and we're gonna after having completed returning all the locations inside the array, we're gonna, in the completed pin, we're gonna call the return node. We're gonna return from this function. That should be all for the do item generation function inside our new custom generator. I'm gonna go now to class defaults and change a setting. Generated item type, because we're generating locations here, they're not actors, so we're gonna select point. That should be all for our new custom generator. We save it, and then we're gonna create a new environment query, which we're gonna call find nearest cover point. Find nearest cover point. Cover location is better as a name, so I'm gonna change this inits and cover location. This is our new environment query. We're gonna call our new generator hiding locations generator, and then what I'm gonna do is gonna leave all this as they are for the settings. Context query, generated item type point, as we've seen, circle radius around the player 1000. Those are test. Alright, I'm gonna add a test to this generator. Now, after having obtaining all the cover locations around the player character, we're gonna test to see the nearest hiding location, the nearest cover location among them to the ranged enemy character. So we're gonna do a distance test to do this. To get this, it's gonna be a score only test, and we're gonna leave everything else as it is. We're gonna just change the scoring factor to get the lesser distance to the ranged enemy. So let's change this to -1, of course. Is it? Okay, -1, yes, should be like that. And that should be all for our environment query. Now, time to test this. Before that, of course, as a security measure, should I call it, in the doItem generation function, in the new generator, we're gonna clear first the returned cover points array. So I'm experiencing a menu problem here. So guys, I will be back to you in a second. Sorry for that. So guys, sorry for that problem. So what we said is we're gonna clear this array first as a security measure, should I call it, and that's it. So now on to testing the new EQS query. So back to the behavior tree. I'm gonna unconnect the root node from the main selector. Gonna do a site behavior tree for testing. New selector, and then run EQS query. That's it. We select our query for this, which is the find the nearest cover location, and that should be all. So blackboard key, we're gonna return the nearest cover location inside a new blackboard key. So we're gonna create a new blackboard key. We're gonna name it cover location. That should be it. So behavior tree, back to the run EQS query task, blackboard key, cover location, and we save all. Save all. Now we're gonna do some cover points inside the level. Gonna just increase the size of the viewport. Gonna select this block, duplicate it with Alt, wait for it to process, rebuilding BSP, building navigation. What's he doing? So alright, so authorized, the new one. Ah yes, now it's selectable. Just wait for it. Be patient. So this is a block. Just drag it there. We're gonna increase its height a little bit. That's it. Like that. That's it. And gonna elevate it a little bit, and on it to move it to the ground. Gonna do another duplication there, another one there, and another one there. So these are potential hiding spots from our player character. So I'm gonna move our player start in the middle, to the middle. We have our arranged enemy there. And what I'm gonna do is I'm gonna hit play to see. So we have our arranged enemy. Not doing anything because we unhooked the behavior tree. For the new one, I'm gonna hit the comma, the apostrophe, sorry. I should aim at him while hitting the apostrophe to get his AI debugging stuff. So yeah, and then I'm gonna select just the EQS, this one, remove the EQS data. So we have our hiding spots around us, the hiding spots from us, and the winner here is I'm gonna check to see, the winner is there. Yes, the winner is that hiding spot, the nearest one to our ranged enemy character. and we have the other hiding spots returned by our custom generator. If I move here, there is a new winner there, the nearest one to him, to hide from my shots. So if I shoot at him later on in this tutorial series, he should go straight to that hiding spot, the nearest one to him. So guys, thank you very much for watching this video, and see you in the next video. Goodbye.